What's up, everyone? Welcome back. In this question, we're told that f of x is equal to 2 to the power of x, and then we have to sketch that function. G of x is equal to 2 f of 2x minus 4 minus 3, and then we have to state some characteristics. So we have to state the y-intercept, range, asymptote, and then the horizontal shift. Okay, so notice this g of x here. It's given in a general format, right? Because we have this f of 2x minus 4. But we know that f of x is equal to 2 to the x. So we know this is the parent function here. So we can actually rewrite g of x as what? 2 times 2 to the power of 2x minus 4, right? This 2x minus 4, basically we're subbing in for that x. Right? Since f of x is 2 to the power of x, then f of 2x minus 4 would be 2 to the power of 2x minus 4. And then this is going to be minus 3. Now, if you remember from the lecture videos, this is not in the proper transformation format yet. We got to have that k value by itself. So we'd have 2 times 2 to the power of 2 bracket x minus 2. And that would end up being minus 3. Right? So that is the function that we have to sketch. So starting off with the parent function, so we got y, or let's actually write f of x is equal to 2 to the power of x. Let's make a table of values for it. So let's just start with 3 points. So -1, 0, and then 1. So 2 to the power negative 1 is what? 0.5. 2 to the power 0 is 1, 2 to the power 1 is 2. So now we've got to take this table here and we have to transform it. Now, what are the transformation values here? What's the a value? What's the k value? What's the d value? What's the c value? Well, the a value is 2. K value is 2 as well. The d value is positive 2, right? It's the opposite sign. And then the c value is negative 3. So basically, we have to put these points here through the formula x over k plus d ay plus c that we went over in the lecture video. So all the x values are going to divide by the k value of 2. Going to add that d value of 2. And then all of the y values we're going to multiply by 2 by the a value. And then we're going to add that c value of minus 3. So plugging in an x value -1 here, -1 over 2 is -0.5 plus 2 gives us 1.5. 0 divided by 2 is 0 plus 2 gives us 2. And then 1 divided by 2 plus 2 gives us 2.5. So that's what the x values transform to. Then the y values, multiplying them by 2, subtracting 3. So 2 times 0.5 is 1, minus 3 gives us -2. And then 2 times 1 is 2, minus 3 is -1. And then 2 times 2 is 4, minus 3 gives us positive 1. Right? So this here is the table for this transform function. You could also use 5 points if you would like. So you could put -2, and then you'd have 0.25, and you could put positive 2, and then you'd have 4. Right? Make it a little bit more exact. But these are fine. These will do. So from here, we just have to graph these points. Now, if you remember, for an exponential function, what you always want to graph, I'm actually going to rewrite these transformation values over here, give myself some more room. So what you always want to graph first is the horizontal asymptote. The horizontal asymptote is actually based on the c value. So we know there's going to be a horizontal asymptote at y is equal to -3. That's actually one of the characteristics here. So we could just answer this question while we're at it. So y is equal to -3. So graphing this, graph the horizontal asymptote that's at y equals -3. And then we just have to graph these points. So an x value 1.5 and -2, that is where? That's over, let's say, here. 2 and -1, let's say that's like here. And then 2.5 and 1, that's like up there. So basically this function is looking something like this. Right, so that there is the graph of g of x. Now that we have the sketch, we can go through these characteristics. So what's the y-intercept? Well, actually in this case, the y-intercept we don't have, so we're going to have to actually find it algebraically. So we know g of x is equal to 2 times 2 to the power of 2 bracket x minus 2 minus 3. So we would find g of 0, right? Because at the y-intercept, the x value is going to be 0. So we would plug in 0 for x. So we'd have 2 times 2. And then this would be 0 minus 2, which is negative 2, times 2 is negative 4. And this is going to be minus 3. So this simplifies to what? We got 2 to the power 1 times 2 to the power negative 4, which gives us 2 to the power negative 3. Right, because they're the same base, and that would be 1 over 8. And then we're going to be subtracting 3. So the 3 we could change to 24 over 8 if we want to get a common denominator. And then 1 minus 24 over 8, that gives us negative 23 over 8, like that. So this here, the y-intercept is negative 23 over 8. Right, has a coordinate of 0, an x value of 0, and a y value negative 23 over 8. You can also get the decimal of that if you want in your calculator. Right, so that's the y-intercept, and we had to algebraically get it by plugging in 0 for the transformed function. What's the range? Well, the range we could tell from the graph. Basically, all of the y values, I'm going to write the range over here. So the y values can be anything, but they have to be greater than negative 3. Right? Remember, the range always depends on that horizontal asymptote, whether the graph is above it or below. In this case, it's above the horizontal asymptote. Then the horizontal shift, that's based on the d value. So d value is positive, so we're going 2 units to the right. Sorry, I was kind of scattered all over the board here for this question. But anyway, those are the characteristics, and that is your graph.